This morning, I bought a broken laptop charger at a scrap market for almost nothing. And from this piece of junk, I'll build a mini welder machine. Stay till the end to support the channel. When it comes to building a low-power mini welder machine using a 19-volt, 90-watt laptop charger isn't a random choice. It's technically sound. Let's look at the numbers. At 19 volts and 90 watts, the current is roughly 4.7 amps. That may not sound impressive, but for mini welding, thin wires, battery tabs, light metal joints, this level of current is enough to generate concentrated heat in short bursts. In real-world comparison, full-size welder machines can consume thousands of watts. But that kind of power is bulky, energy-hungry, and completely unnecessary for small DIY tasks. Here, the goal isn't brute force. It's controlled energy for a specific job. Another practical advantage of laptop chargers is stability. They're designed with built-in protection against overcurrent and overvoltage, making them far safer than homemade transformers. So while they weren't designed for welding, they turn out to be a surprisingly good foundation for a compact, efficient mini welder machine. With the output cable of this laptop charger, the first step is to separate and identify each wire clearly. You'll typically find a positive wire, a negative wire, and sometimes a ground or earth wire. For a mini welding machine, the ground wire isn't necessary, so it can be safely removed to keep the setup simple. The real issue, however, is that you cannot reliably tell which wire is which just by looking at them. In electrical work, connecting the polarity incorrectly doesn't just fail the project. It can trigger protection circuits, cause short circuits, or even damage the charger. That's why the only accurate method is to use a voltage measuring device, such as a multimeter. When you measure, the pair of wires that shows a stable reading of around 19 volts identifies the true positive and negative. Any wire that shows no clear voltage is usually the ground wire. DIY isn't about guessing. It's about measuring and confirming. Get this step right, and everything that follows becomes safer, cleaner, and far more reliable. After removing the ground wire, only two main wires remain. The red wire is positive and the white wire is negative. That clearly identifies the power polarity and helps avoid mistakes during wiring. Next, I'll extend the length of both wires, making the mini welding machine easier and safer to work with. And once again, it's the spark plug, a familiar component that has appeared in many of my previous welder machine builds. If you've been following the channel for a while, this part probably looks very familiar. I keep using spark plugs for a simple reason. They handle heat extremely well and come with a solid threaded body, which makes them perfect as the core of a welding tip. They're durable, easy to find, and very affordable. To connect the threaded end of the spark plug to the welding tip, there's no need for anything complicated. I'll reuse the metal connector block from inside a standard electrical terminal. This metal piece works as an intermediate adapter, creating a strong mechanical connection while also providing excellent electrical conductivity. With just a bit of simple modification, it's ready to use. Small details like this, when done properly, make the entire mini welding machine far more stable, clean, and reliable. New on. Would you believe that the core inside a completely drained AA battery can be turned into a DIY welding tip for this device? It sounds hard to believe at first, but once you take a closer look, the idea actually makes a lot of sense. Inside an AA battery, when the energy is fully depleted, the chemical materials are no longer useful. However, the metal core in the center remains intact, far from being useless, as many people assume. This core is usually made from a material with good electrical conductivity and reasonable heat resistance. More importantly, it has a small cylindrical shape, which is ideal for concentrating heat into a precise point. For a low-power mini welding machine, you don't need a large or complex welding tip like those used in industrial welders. What really matters is a tip that conducts electricity well, heats up quickly, and stays rigid enough for accurate control. And when placed correctly, the AA battery core meets all of those requirements. Something most people would throw away ends up becoming a simple, affordable, and surprisingly effective DIY welding tip. At this stage, the DIY welding tip is complete. When installing it in the correct position, be sure to tighten the screw carefully. The structure of this tip is quite brittle, especially near the heat-exposed area. If you rush or apply too much force, it can easily crack or break. So take it slow, tighten gradually, and feel the resistance, because patience here means a more durable and reliable welding tip. Next, we'll connect a positive wire from a laptop charger to the contact terminal of the connector block in the spark plug welding tip assembly. This is the point where power is delivered directly to the welding tip, so the connection needs to be firm, aligned, and secure. As long as the polarity is correct and the contact is tight, the current will flow smoothly and reliably to the tip. To protect the connection joint from coming loose or breaking during welding, using electrical insulation tape is a very practical solution. The tape helps secure the wire firmly, reduces movement while working, and provides proper insulation to prevent accidental short circuits. As long as it's wrapped neatly and tightly enough, the connection will remain safe and stable throughout the process. As for the remaining negative wire of the laptop charger, I'll connect it to an alligator clip. This clip will attach directly to the workpiece, completing the electrical circuit during welding. It's convenient, easy to use, and quick to remove, which makes it ideal for a simple mini welding setup like this. So everything is almost ready now. I'll set everything up here, and then we'll move on to the testing stage. The part one know many of you have been waiting for. In reality, this test is only meant for welding small, thin metal pieces together. It's not something you can, or should, expect to perform like a full-size professional welding machine. This is a DIY mini welding setup, built with limited power for light tasks. As long as it does what it's designed to do, that's already a successful result. These small tests didn't pose any challenge at all for this laptop charger mini welding device. When working with thin and small metal pieces, the setup remains stable and produces welds that are strong enough for light testing and simple repairs. Of course, it's important to be clear, this is not a full-size professional welding machine. It's not designed for thick materials, nor for continuous heavy-duty use. But when you place it in the right context, as a low-power DIY tool built from affordable, reused components, the results make complete sense and are perfectly acceptable. What really matters here is understanding the principles and knowing how to reuse what would normally be thrown away. That's how simple ideas turn into working tools. Thank you for watching until the end, and I'll see you in the next DIY project.